All right. So let's kind of go over what we where we left off last time. I introduced this idea of a function, which was a kind of simple subject, but we just had different notation for it. We've been working with things that look like functions all throughout the semester, but instead of just saying like y equals something with x's in it, we use this notation y of x. So y of x, or more frequently, some letter like f of x, right? And all this meant was everything on the right was just a normal equation that we've been seeing so far. And instead of writing y, we write f of x, okay? And I know it's a little bit bulky, but it tells us a lot of information about what's on the right-hand side. Whatever's in the parentheses is the input or the x values that we substitute into the equation. And f of x is kind of like the name of our function. So it represents kind of like the y values of the function. Okay. We did a lot of examples with functions, so we were able to plug in different things into our function. And I think now we're going to sort of switch gears here to talk about some different things that we can see involving functions. Okay. I know this is kind of scary. I think domain and range kind of scares some people off. And I promise you it's not that hard once you kind of understand, well, the things to look out for. So let's just kind of go over things. I'm sure that we've heard these words before, but whenever we talk about a function's domain, we're thinking about all the inputs we can put into the function. So it basically describes all of the x values or anything on that horizontal axis that is allowed to be taken into the function. And if that doesn't make sense, maybe in an example will clarify some things. And on the other hand, the range represents all the y values, so all the outputs of the function. Where does the function actually exist from the bottom to the top? Okay. I think the easiest way to deal with functions is to draw a picture and see what happens. And a lot of the times we have the picture already drawn for us, which is really great. Okay. So I have a function here. Why is it a function? Does anyone remember? What sort of test did we have to pass for something? The vertical line test, right? So if I drew a vertical line from the top to bottom and I moved it from the left to the right, well, the vertical line would only touch the graph once. Now, looks a little weird here. Why does the function pass the vertical line test at x equals 3? Yeah, right. It looks like the function touches this vertical line twice at this point, but since there's an open circle of around 2, the function actually doesn't exist here, okay? What this graph is saying is at x equals 3, the function jumps from 2 to -2, but it doesn't actually equal 2 at 3, okay? Anyone know what this type of function is called? I think I have actually heard it be called the step function. I'm thinking of a different one though. It's actually, normally it's called the piecewise function. And I'm not going to write step because I do think it's called that, but there is a very particular type of piecewise function that is also called the step function. So we'll call it this. Okay. We might deal more into these a little bit later in the class. All right, some questions before we start talking about domain and range. The first thing we're going to do is find g of 0. All this means is we're taking our function, which is named g, and 0 is kind of like our input, right? So this is the x value. Okay, so can someone tell me what the y value is at 0? 2, right? Because when x equals 0, we're here, and the y value, or the value of the graph, is 2. Okay, so g of 0 equals 2. Any questions so far? Oh. Oh, yeah, you're good. Does anyone else need a copy of the notes from last? Yes. Right, continuing on, let's do something slightly harder. We are going to do g of 3. So we're plugging in 3. So we're looking at the x value 3. What is the y value when x equals 3? -2, right? Even though it kind of looks like the function exists up top, it actually doesn't because there's an open circle. Okay. Now, if you flip to the back, you'll be able to write the domain and range down if you want that. Since the graph is here, I'm just going to write it kind of next to the graph because I like to see what I'm working with here. Okay, let's do domain first. Okay. Remember, the domain is all the x values where the function exists, okay? Looking at this graph, can someone kind of tell me any x values that might not work for the graph? 4, let's see. Well, at x equals 4, does the function exist? Yeah, the function does exist there. Any other ideas? 3 is a good one, right? Because, well, the function doesn't exist up there, but it does exist there. So the function actually does have a value at 3, but that's a good guess. Any other values that might not work? Someone say 5. Yeah, at x equals 5, if I looked up, there's no function. If I look down, there's no function there either, right? Oh, here we go. Okay, so the function actually doesn't exist at 5, right? So we know that it doesn't exist here, so I'm going to put a little X mark at 5. Okay, any other values? -5, right? The function wouldn't exist at -5 because if I sat my, if I kind of stood at x equals 5 on the x-axis, or -5, if I looked up, there'd be no function. If I looked down, there'd be no function. Well, the function doesn't define a -5. Is there anyone who can kind of consolidate all the points where the function does exist? Yeah, from -4, x equals -4, let's see, all the way to x equals 4, we have values where the function lies, right? But anything to the right of 4 and anything to the left of the 4 doesn't have a picture, right? So there's no way the function can exist there, okay? So our domain is essentially between x equals -4 and x equals 4. Now, we do have to do a little bit more work because are we including -4 and 4 here? Does the function exist at 4? Yeah, right. I kind of just explained why. And the function exists at -4 because we have closed circles here, right? This is a closed circle. And this is also closed. So therefore, we're going to include them, including -4 and 4. Okay. Is there a way to write this a little bit more precisely? I see, right? So you're using the notation that we use for the inequality section to write our answer. And actually, this shows a lot of information because it says between -4 and 4, we're including those points too, and that's why we have brackets instead of parentheses. Okay. Sometimes you'll see this X with this symbol. Okay. But if you're doing a problem on WebAssign, and you're asked to find the domain and range, you probably want to use this notation because it's very precise and it's kind of what it's looking for. Okay. Any questions on the domain? All right. Going over to the range, I'm going to write this in maybe not yellow, but pink color. Range. Okay. On the other hand, the range is telling us what the y values the function exists at. Okay. So where does the function actually have values? Okay. So instead of focusing on the x-axis, maybe we should focus on the y-axis, right? What y values does my function exist at? Okay. Can someone tell me a y value the function exists doesn't exist at? Yeah, -4. If I sat at -4, I look to the right and left, there's no function in the picture, right? And if I was at +4 and look to the right and left, there still wouldn't be a picture. So at those points, the function doesn't have a value. Is there someone who can kind of piece together what this range might be? Between what values the function exists?
3 and 2.
Yeah, between -3 and 2, right? Now, are we including -3 and 2?
Mhm.
Yeah, right, because if I look over here, there's a closed circle, and over here, there's a lot of values where the function has a value at 2, okay? Even though there is a closed circle technically here, the function exists at all of these other points, so we're going to include 2. So in set builder notation, we can say -3 and 2, and since we're including them, we can put them in brackets. Okay. Oh, and we'd say either y or g of x is between these two numbers. Okay. Any questions on domain and range? All right. You might be on the back of that page already, but if you were working next to the graph as well, just turn your page over. I want you to work on example 8 for a little bit, very similar to what we've done here, but you might have to think a little bit harder about some of the range values and the domain values. All right, I know some of you are still working, but I do want to go over example 8 a little bit more slowly since we're getting used to the idea of domain and range, so that we have a little bit better idea of what these values mean, okay? I think it was pretty good as I was walking around, but what did we say f of 1 was? I think I heard it 1, right? Because, well, when x is 1, y goes up to 1, and that's where the closed circle is. So it doesn't really matter if there's any open circles. We really want to focus where the closed circle is. Okay. F of 2. What value was f of 2? 3, good, because there's a closed circle at 3 when x is 2. Okay. So let's talk about domain. Domain are the x values that we can plug into the function. Looking at this graph, are there any x values that we can get something that doesn't exist? Okay, Stephen said 2, which it does look like the function doesn't exist at 2, so I'll give you credit for that. But at 2, the function does exist at 3, so that would be part of the domain. Any other values of x? Yeah, right, because look at this. This line has an arrow at the end, and that means it's just continuing on over to infinity. The same with this line. It has an arrow there, so it says this line is going to extend to the left forever and ever and ever, right? So this function doesn't actually stop. And at the points where it looks discontinuous or that it has a jump to it, the function is defined. So when we look at this, there's actually no values that don't work for the function. Everything works, okay? And instead of writing that everything works, normally what people write is all real numbers, which means that x can be any number from the real numbers. You might also see this number, r, okay, but it has like a little bold thing to it. So if on WebAssign you see that, that's all that means, okay? How would I write this in set builder notation? Yeah, -infinity to infinity. And should I put parentheses or brackets? Parentheses, right? Remember, infinity always gets a parentheses, no matter in what situation you're in. Any question on the domain? All right. Taking a look at the range, we're looking, instead of the from like left to right, what values on the x-axis can we plug in? We're looking from the top to the bottom. What y values does the function have a picture? Okay. Can someone tell me any y value that doesn't work? Yeah, at -1, if I look from the right to the left, there's no picture, right? And actually, any negative number isn't going to work, right? Okay. So in set builder notation, how can I write the range? Good, bracket 0, comma, infinity, because, well, from 0 up on up, we have the function, so that's why we have an infinity here. Why do we have a bracket at 0? Yeah, it's included. I know there's no closed circle, but this line basically represents a bunch of closed circles kind of strung together, right? So whenever there's a line or a closed circle, we're going to use a bracket. Okay. Any questions on this example? Okay. I think we're getting a little bit used to looking at the domain and range based on the picture. Let's do a few more examples and see what happens. Okay. So now we're gonna kind of stray away from the picture, even though we'll end up drawing pictures a little bit later. But this time I'm just given a function, okay? And I wanna know the domain and range. Let's start with the domain, okay? And I'm gonna say for the domain, you actually don't need to draw a picture. You always can, but sometimes it's a little bit easy to do in your head, okay? Now, remember, the domain are all the x values that we can plug into the function, okay? So that means anything I can plug in here. Can someone tell me if there's any x values that I can't plug in here? Can I plug in like 1? Yeah, it'd be 1 plus 5, which is 6. Can I plug in negative numbers? All right, let's try it. We can plug in f of -1. That'd be -1 plus 5, and it'd give us 4, which is a normal number. Okay, so it looks like negative numbers work. Can I plug in decimals? Let's see. We can plug in. Let's do point. Let's do a fun one. Like, let's do 1.618, which is actually called the golden ratio. If you ever heard of it. But let's plug this one in. 1.618 plus 5. That gives us 6.618. Okay, so we can plug in decimals. Is there anything that I can't plug in here? Yeah, okay. Let's just focus on the real numbers, but that's a good one. Any other numbers I can't plug in? Oh, right. It looks like everything works on this graph. Okay, so the domain is going to be all real numbers, Stephen. And another way to write this is negative infinity to positive infinity. Okay. So when we look at the domain, we're just looking at what can I plug in, what can't I plug in, and let's see if it works or not. Okay. Now for the range, I always recommend drawing a picture because it's really hard to determine what y values something has just looking at the equation of something. So we know how to draw this. We have a linear equation. What's the y-intercept? 5, right? So at 5, we've got our point, okay? And if our function is x plus 5, what's our slope? 1, good. Okay, so our graph kind of looks like this. Okay, well, it makes sense that our domain was all real numbers because it looks like our graph doesn't have any holes in it and it's going to infinity on both ends. Okay, what do you think the range is? All real numbers, right? If I go from top to bottom or bottom to top, there's going to be no holes in our graph. There's no place where our graph doesn't exist. So this one is also all real numbers, or negative infinity to infinity. Okay. I'll just put that on time here. Okay. All right. Let's go to example 10. This one's a little bit different. Okay. We want to find the domain and range of g of x equals 2. Okay. So let's take a look at the domain. Are there any x values that I can't plug in here and get unreasonable answer? No, right? And if you have trouble imagining this, I do recommend drawing the picture if you ever get confused. Is g of x equals 2 a vertical line or a horizontal line? Or is, I heard both vertical and horizontal. Okay, another way of writing g of x equals 2 is saying y equals 2, right? So when y is 2, it doesn't matter what our x value is, y is always going to be 2, so it's actually going to be a horizontal line. So as we said, the domain is all real numbers here because this line extends on forever. Of course, we have all real numbers, or negative infinity to infinity. What do you think the range is?
Wouldn't it just be two?
Yeah, it's just 2. Any other number on the y-axis doesn't have a picture to the left or to the right, right? The only number on the y-axis that has a picture is 2 because we have a horizontal line here, okay? So the range is just the value 2, okay? And I know there's really no way to write this in set builder notation. The way this is written is to write 2 and put it in like curly brackets. Okay, so when you have an isolated number or an isolated list of like maybe 4 numbers, we use like curly braces instead of brackets or parentheses. Okay. Yeah. Any questions on example 10? All right. Okay, let's continue as a class here. Example 11, we want to find the domain and range of f of x equals x squared, okay? So let's take a look at the domain. Anything I can't plug in here? No, right? I can plug in any number and square it. I can even square a negative number if I wanted to, right? So the domain here is all real numbers. Let's talk about the range. When we do range, I always like to draw a picture, okay? Now you can plot points to draw this, but I think we can do this in our heads. X squared has a very specific shape. Does anyone know the name for it? Starts with a P. Parabola, right? So it looks like a U. And is the U shape facing up or is it facing down? It's facing up, and that's because the coefficient or the number in front of x squared is positive. Okay, if it were negative, the parabola would face down. So this actually looks like this. Okay. Looking at this graph, what's the range of this graph?
0 to
Good. And do I have a bracket or a parentheses on 0?
bracket.
Bracket, good, because we're including it. All right. Any questions on example 11? I think we're getting a little bit good with looking at a basic graph and trying to find the domain and range. Let's go to more complicated graphs. When we talk about domain, and I'm really going to start focusing on domain now, okay? There's going to be 2 things in a function that mess people up, okay? Or mess you up when we're finding the domain. The first thing that comes up are square roots. And the second thing that happens is when we have a denominator. Okay, so 2 things that we say restrict the domain or make the domain a little bit smaller than what we're used to are square roots and denominators. Okay, we're going to focus on the square roots first, and then we'll talk about what happens when we have stuff in the denominator. Okay. Before we even talk about this, I'm going to give you the graph of the basic square root function, which is y equals the square root of x, or in function notation, f of x equals the square root of x. Okay. The square root function always has this shape. It kind of looks like a parabola cut in half almost, but it increases a lot faster than like a normal parabola would. Actually, it doesn't. Sorry. I'm sorry I said that. It just looks like a parabola cut. Sorry about that. Okay. Looking at this, let's find, well, I don't know if I want to do this. Yeah, I want to do this. Okay. What's the domain of this square root function? 0 to positive infinity. And does anyone know why looking at the function and looking at the graph, why is this domain stopping at 0 or starting at 0? What about the square root function is making the graph not exist at 0? It kind of is the x. The square root of 0 is 0. Okay, so that's why the function does exist at 0. Why doesn't the function exist at -2? Yeah, right, because at -2, if I wanted to find the function, I would plug -2 in for f, right? And that would be the square root of -2. Now, we did a lot of work with square roots, and we do know that this is the square root of 2i, right? But we're looking at real numbers. We're not doing imaginary numbers. There's actually a whole new coordinate system that we use to graph imaginary numbers that we don't want to work with right now. Yeah, so for this sort of coordinate system, we're just dealing with real numbers. And the function doesn't exist whenever we have something negative in for square root, okay? So the reason for this is because you can't take the square root of a negative. Okay. Another way of saying this is the inside of the square root always has to be bigger than or equal to 0, right? So everything under the square root or the inside has to be bigger than or equal to 0. Let's talk about range real quick. Looking at the picture, what is the range of this function? 0 to infinity, good. Okay, we actually are including 0 because the function does start at 0. But I'm going to kind of stray away from range here and kind of just focus on the domain. Okay. So the whole idea with square roots is when we're finding the domain, you're going to take the inside of the square root and set it greater than or equal to 0. Here's an example, a little bit harder than what we've done before. Okay, let's find the domain of this function. Okay, let's pretend that we haven't seen the graph yet, so we don't actually know where the domain is. And actually, looking at the graph, it's kind of hard to see where it actually starts. Okay. Okay. The domain of a function, especially when we have a square root, means we have to take this inside piece, okay, which is 2t minus 5, right? That's everything underneath the square root. And we're going to set that greater than or equal to 0. So everything on the inside has to be bigger than 0. How would I get t by itself? Yeah, add 5 to both sides. So we're at 2t is greater than or equal to 5. Okay, and then I guess I have to divide by 2. So t, do I switch the sign? No, right? When I'm dividing by a positive number, I keep the sign the same. And t is bigger than or equal to 5 over 2. Okay, so my domain, looking at this symbol, and of course you can graph this out on a number line. Can someone tell me in set builder notation what the domain is? Perfect. Am I putting a bracket or parenthesis around 5 halves?
Bracket.
Bracket. And infinity always gets a parentheses. Okay. So our domain says that any input or x value or t value in this case has to be bigger than 5 over 2. Looking at our graph, that makes a lot of sense because it looks like the graph starts around 5 over 2. Okay. Looking at the picture, just for fun, what's the range? Good, 0 to infinity. Any questions on the square root function? Okay, I'll do one more and I promise you I'll let you try some on your own. Oh yeah, we do have a quiz, don't we?